Our group project is to perform a prediction on the mobile phones price ranges. So for my part, I will be doing the experiment set 4, which is to vary the training sample size. And then our topic is to perform a supervised classification algorithm to achieve the prediction of mobile phone price range. And our meaning of the price range is less than 500 for low range, 501 ringgit to 1,500 for mid range, and above 1,501 ringgit will be the high range. And for our choice of metric to evaluate the model's performance, we will be using F1 weighted score because our data set is highly imbalanced. So F1 weighted score is the choice of scoring to avoid the shortcoming of accuracy metric on evaluating the imbalanced data set. For our training and testing split part, we will at first use the 80% of the data set as the training set, and the 20% will be the test set. On top of the 80% of the training set, we will split the 80% training set into 10 parts, and we will use the 10-part data set to perform the varying of sample size or to see the effect of bigger sample size on the data on training the model. So our methodology of experiment is to use the first 10 part is to from the previous is to shuffle and split the 10 part of the data, and then we will first use the first 10% part to train the model, and then we will use the model to validate against the original 20% test set and record the result. After that, we will add another 10% of the training set on top of the previous part to train the model, and then we will repeat the experiment from 10% of the training set until 100% of the training set, and we will observe the result for each of the classifier model. So this is our result for K nearest neighbor classifier. Basically, K nearest neighbor classifier is getting a higher F1 score with a higher number of training data. There is a big improvement on 20% and 40%. However, there are still some slight hiccup on the improvement of F1 score. For example, at 30%, 80%, and also 100%. The F1 score peaked at the 90% of the training data where it reached its highest. The F1 score, however, dropped at 100% training data, despite with 10% more data, where this also happened in the another two classifier in the upcoming slides. The F1 score for gradient boosting classifier shows very visible improvement until it reaches the 50% of the training data. And then it reaches its highest F1 score at 70% training data. The growth of the F1 score on gradient boosting is rather slow, and surprisingly, the F1 score dropped a little bit on 100%, which also happened in the next classifier. In the second classifier, the F1 score shows good improvement until 50% training data. And from 50% onwards, the F1 score starts to fluctuate around 66% and 67%. And coincidentally, the F1 score also dropped on 100%, although very minimally. Hence, we could suspect that the last 10% of data is outlier, since it is able to consistently bring down the F1 score for the three classifier models. And this is the end of my presentation.